NFPA 70, the National Electrical Code, Article 336.12b, Raceway and firestops, states that where a raceway passes through a firestop, the raceway shall be sealed with approved materials to maintain the firestop rating. Article 300.22c, Raceway installations through walls, floors, or ceilings, specifies that raceways passing through holes in walls, floors, or ceilings shall be sealed with an approved material to prevent the passage of fire and smoke. Based on the NEC, any raceway, including PVC and EMT, passing through a fire-rated wall, floor, or ceiling must be sealed with an approved material to maintain the fire rating of the barrier. This is true even if the raceway does not penetrate the firestop material. Therefore, in the case of the fire chase, both the electrical and lightning protection raceways must be sealed with an approved material where they pass through the openings in the chase. Let's consider some additional information. Firstly, the fire chase definition. A fire chase is a vertical shaft used to conceal vertical fire-rated assemblies such as standpipes, plumbing, and electrical. Fire chases are typically enclosed in fire-rated walls or partitions. Secondly, we should describe what a fire barrier is. A fire barrier is a wall, floor, or ceiling that is constructed to resist the spread of fire and smoke. Fire barriers are typically made of fire-rated materials such as gypsum board or concrete. Thirdly, we should look at penetrations. Any opening in a fire barrier, such as a hole for a raceway, is a potential point of failure for fire containment. Penetrations must be properly sealed to maintain the integrity of the fire barrier. In order to comply with the NEC and ensure fire safety, all electrical and lightning protection raceways passing through the fire chase should be sealed with an approved material. This will prevent the passage of fire and smoke and maintain the fire resistance of the chase. To further clarify, the National Electrical Code, or NEC, serves as the benchmark for safe electrical design, installation, and inspection to protect people and property from electrical hazards. It is updated every 3 years. Article 300 covers wiring methods and materials. Article 300.4 addresses protection against physical damage. This section requires wiring methods to be protected from damage where they pass through floors or walls. Sleeves, bushings, or other approved methods must be used to protect the wiring. Article 300.11 focuses on securing and supporting wiring methods. Wiring methods must be securely fastened in place. This section also prohibits the use of ceiling support wires or ceiling support systems to support raceways. Article 310 addresses conductors for general wiring. This section specifies requirements for conductor insulation, ampacity, and installation. Article 310.15 details ampacity calculations for conductors. The ampacity of a conductor is the maximum current, in amps, that it can carry continuously under specific conditions of use without exceeding its temperature rating. The NEC provides tables that list the ampacities of conductors based on their size, insulation type, and installation conditions. These tables take into account factors such as ambient temperature and the number of current-carrying conductors in a raceway or cable. Correction factors are applied when the ambient temperature exceeds 30 degrees Celsius or 86 degrees Fahrenheit, as specified in Table 310.13 Bone. Adjustment factors are used when there are more than 3 current-carrying conductors in a raceway or cable, as outlined in Table 310.15b3. These factors reduce the allowable ampacity of the conductors to prevent overheating. In the specific scenario of a fire chase, several NEC articles and sections come into play. Article 300.21 addresses the prevention of fire spread. This section requires that electrical installations be performed in a manner that minimizes the spread of fire or products of combustion. This is particularly relevant to fire chases, which are designed to contain and prevent the spread of fire between floors or areas. Article 336 covers non-metallic sheet cable, types NM, NMC, and NMS. While PVC conduit is not specifically addressed in this article, the general principles of fire stopping and sealing penetrations apply to all wiring methods, including those installed in PVC conduit. Article 314 addresses junction boxes, pull boxes, and conduit bodies. This section specifies requirements for the installation of boxes and conduit bodies, including their support, accessibility, and fire resistance. Boxes and conduit bodies installed in fire-rated walls or ceilings must be listed for use in fire-resistant construction. Article 725 covers Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits. These circuits are often used for control and signaling systems in buildings. The requirements for fire stopping and ceiling penetrations also apply to these circuits. To ensure compliance with the NEC, it is essential to understand the specific requirements for fire stopping and ceiling penetrations in fire-rated walls, floors, and ceilings. This includes selecting approved materials, properly installing the fire stops, and inspecting the installations to verify their integrity. Approved materials for fire stopping include listed fire stop sealants, putties, and devices. These materials are tested and listed by organizations such as Underwriters Laboratories or all to meet specific fire resistance ratings. Fire stops must be installed in accordance with the manufacturer's instructions and the listing requirements. This includes filling all voids and spaces around the penetrating items such as raceways and cables, and ensuring that the fire stop material is properly bonded to the surrounding construction. Inspections should be performed to verify that the fire stops are properly installed and that they meet the required fire resistance rating. This includes checking for gaps, cracks, or other defects in the fire stop material, and verifying that the fire stop is properly bonded to the surrounding construction. In addition to the NEC requirements, local building codes and fire codes may also impose additional requirements for fire stopping and ceiling penetrations. It is important to consult with the local authorities having jurisdiction or OJ to determine the specific requirements for a particular project. In summary, the NEC requires that all penetrations in fire-rated walls, floors, and ceilings be properly fire-stopped and sealed to prevent the spread of fire and smoke. This includes penetrations for raceways, cables, and other electrical equipment. The specific requirements for fire stopping and ceiling penetrations are outlined in Articles 300.21, 336.12b, and other relevant sections of the NEC. Compliance with these requirements is essential to ensure the safety of buildings and their occupants. The integrity of a fire-rated assembly, whether it be a wall, floor, or ceiling, is paramount in containing a fire and preventing its spread. Any penetration through these assemblies, such as those for electrical conduits, plumbing pipes, or HVAC ductwork, creates a potential pathway for fire and smoke to bypass the barrier and compromise its effectiveness. Therefore, it is crucial to properly seal these penetrations with fire-rated materials and methods that maintain the fire resistance rating of the assembly. The National Electrical Code, or NEC, addresses the requirements for fire-stopping electrical penetrations in Article 300.21, which states that electrical installations shall be made in a manner that minimizes the spread of fire or products of combustion. This section requires that any openings around electrical penetrations be sealed with approved materials that are designed to resist the passage of fire and smoke. The NEC also references other standards, such as those published by ASTM International and Underwriters Laboratories, or all, that provide specific requirements for fire-stopping materials and methods. These standards specify the performance criteria for fire-stopping materials, including their ability to resist the passage of fire, smoke, and hot gases for a specified period of time. The fire resistance rating of a fire stop system is determined by testing the system in accordance with these standards. The rating is expressed in IRs, such as 1 IR, 2 IRs, or 3 IRs, and indicates the amount of time that the system can withstand exposure to a standard fire test without failing. The selection of appropriate fire-stopping materials and methods depends on several factors, including the type of fire-rated assembly being penetrated, the size and type of penetration, and the required fire resistance rating. Some common types of fire-stopping materials include fire-rated sealants, putties, foams, and wraps. Fire-rated sealants are typically used to seal small gaps and cracks around penetrations. They are available in a variety of formulations, including silicone, acrylic, and intumescent materials. Fire-rated putties are similar to sealants, but they are thicker and more pliable. They are often used to seal larger openings and irregular shapes. Fire-rated foams are expanding foams that are used to fill large voids around penetrations. They are available in both rigid and flexible formulations. Fire-rated wraps are flexible sheets of material that are wrapped around penetrations to provide fire protection. They are often used to protect plastic pipes and cables. The installation of fire-stopping materials must be performed in accordance with the manufacturer's instructions and the applicable built-in codes. It is important to ensure that the materials are properly applied and that all gaps and voids are completely filled. The installation should also be inspected by a qualified professional to verify that it meets the required standards. In addition to the NEC, other codes and standards may also apply to fire-stopping installations. These include the International Building Code, or IC, the International Fire Code, or IFC, and the National Fire Protection Association, or NFPA 101 Life Safety Code. These codes provide additional requirements for fire stopping, including the types of materials that are permitted to be used, the methods of installation, and the inspection procedures. It is important to consult with the local authorities having jurisdiction, or OJ, to determine the specific requirements for fire stopping in a particular location. In summary, fire stopping is a critical component of fire protection in buildings. It is essential to properly seal penetrations through fire-rated assemblies to prevent the spread of fire and smoke. The NEC and other codes and standards provide detailed requirements for fire-stopping materials and methods. It is important to select appropriate materials, install them properly, and inspect the installation to ensure that it meets the required standards. Failing to properly fire-stop penetrations can have serious consequences, including the rapid spread of fire, increased property damage, and loss of life. Therefore, it is crucial to take fire stopping seriously and to ensure that all penetrations are properly sealed. Let's delve further into the specific aspects of electrical installations within fire chases and their compliance with the National Electrical Code, or NEC. A fire chase, as previously defined, is a vertical shaft designed to contain and protect fire-rated assemblies, including electrical conduits, plumbing pipes, and other essential building services. The primary purpose of a fire chase is to prevent the spread of fire and smoke between floors or areas of a building. As such, any electrical installation within a fire chase must adhere to strict fire safety standards to maintain the integrity of the fire-rated enclosure. The NEC provides comprehensive guidelines for electrical installations in various environments, including fire-rated assemblies. Several articles and sections of the NEC are particularly relevant to electrical installations within fire chases. Article 300.21, Spread of fire or products of combustion, is a fundamental requirement that applies to all electrical installations. It mandates that electrical equipment be installed in a manner that minimizes the spread of fire or products of combustion. This means that any openings or penetrations created for electrical wiring or equipment must be properly sealed with approved fire-stopping materials. Article 314, Boxes and Conduit Bodies, addresses the requirements for electrical boxes and conduit bodies installed in fire-rated walls, floors, and ceilings. It specifies that boxes and conduit bodies used in these locations must be listed for use in fire-resistant construction. This listing ensures that the boxes and conduit bodies have been tested and evaluated for their ability to withstand fire exposure without compromising the fire resistance of the assembly. Article 330, Metal Raceway Systems, covers the requirements for metal raceways, such as electrical metallic tubing, or IMT, intermediate metal conduit, or IMC, and rigid metal conduit, or RMC. These raceways are commonly used in electrical installations to provide physical protection and a grounding path for electrical conductors. When metal raceways pass through fire-rated walls or floors, they must be fire-stopped to prevent the spread of fire and smoke. Article 344, Rigid Metal Conduit, or RMC. Article 352, Rigid Polyvinyl Chloride Conduit, or PVC, and Article 358, Electrical Metallic Tubing, or IMT, provide specific details on the installation and support of these types of conduits. Although PVC conduit is permitted in some applications, its use in fire chases may be restricted due to its combustibility. The NEC generally favors the use of metal raceways and fire-rated assemblies because of their inherent fire resistance. When PVC conduit is used, it must be carefully fire-stopped to prevent it from melting or collapsing in a fire, which could create a pathway for fire and smoke to spread. Article 725, Class 1, Class 2, and Class 3 remote control, signaling, and power-limited circuits covers the requirements for low-voltage electrical circuits used for control, signaling, and communication systems. These circuits are often installed in fire chases to connect various building systems, such as fire alarm systems, security systems, and building automation systems. The NEC requires that these circuits be installed in accordance with the applicable requirements for fire stopping and sealing penetrations. In addition to the NEC, local building codes and fire codes may also impose additional requirements for electrical installations in fire chases. These codes may specify the types of fire-stopping materials that are permitted to be used, the methods of installation, and the inspection procedures. It is essential to consult with the local authorities having jurisdiction or ODJ to determine the specific requirements for a particular project. The selection of appropriate fire-stopping materials for electrical installations in fire chases depends on several factors, including the type of raceway or cable being used, the size of the penetration, and the required fire resistance rating. Some common types of fire-stopping materials include fire-rated sealants, putties, foams, and wraps. Fire-rated sealants are typically used to seal small gaps and cracks around penetrations. They are available in a variety of formulations, including silicone, acrylic, and intumescent materials. Intumescent materials expand when exposed to heat, which helps to seal the penetration and prevent the passage of fire and smoke. Fire-rated putties are similar to sealants, but they are thicker and more pliable. They are often used to seal larger openings and irregular shapes. Fire-rated foams are expanding foams that are used to fill large voids around penetrations. They are available in both rigid and flexible formulations. Fire-rated wraps are flexible sheets of material that are wrapped around penetrations to provide fire protection. They are often used to protect plastic pipes and cables. The installation of fire-stopping materials must be performed in accordance with the manufacturer's instructions and the applicable building codes. It is important to ensure that the materials are properly applied and that all gaps and voids are completely filled. The installation should also be inspected by a qualified professional to verify that it meets the required standards. In summary, electrical installations within fire chases must comply with strict fire safety standards to maintain the integrity of the fire-rated enclosure. The NEC provides comprehensive guidelines for these installations, including requirements for fire-stopping, raceway systems, and low-voltage circuits. Local building codes and fire codes may also impose additional requirements. It is essential to consult with local authorities having jurisdiction, or ODJ, to determine the specific requirements for a particular project. By adhering to these standards, electrical contractors can help to ensure the safety of buildings and their occupants.